Dear friends, with this video we are going to the chapter on motion part 2. In this part we will be discussing the rate of change of velocity, the accelerated motion, the graphical representation of motion, the distance time graph, the speed time graph and the velocity time graph. In uniform motion along a straight line, the velocity of an object remains constant with time, that is, there is no change in velocity. So, in other words, we can say that change in velocity of an object in any given time interval is 0. However, if the motion is non-uniform, the velocity varies with time and has different values at different instants and at different points of the path of motion of the body. The change in velocity of an object in non-uniform motion during any time interval is non-zero. Let us now express the change in velocity of an object and the rate at which it changes in mathematical form, because there are some objects which speed up at a faster rate, that is, their rate of change of speed or velocity is larger as compared to those which speed up at a slower pace. For the purpose, we define a physical quantity called acceleration. The acceleration of a body is defined as the change in velocity of the body per unit time. Simply put, we also call it the rate of change of velocity with time. Mathematically, acceleration is change in velocity over time. If the velocity of an object changes from an initial value u to a final value v in time t, we express acceleration a as v minus u upon t. Motion with changing velocity is called accelerated motion. Acceleration along the direction of velocity is taken as positive. Acceleration opposite to direction of velocity is taken as negative. The SI unit of acceleration is meter per second square. The velocity of an object may change at a constant rate or it may change at a variable rate. Accordingly, we say that acceleration is uniform or non-uniform. Uniform acceleration is the acceleration if the object travels along a straight line, that is, it doesn't change its direction, and its velocity increases or decreases by equal amounts in equal intervals of time. An example of uniformly accelerated motion is the motion of a freely falling object, that is, an object which falls under the action of gravitational force is uniformly accelerated. The acceleration of an object may also be non-uniform. This is when the velocity changes at different rates at different intervals of time. For example, if a car is traveling along a straight road, increases its speed by unequal amounts in equal intervals of time, then the car is said to be moving with non-uniform acceleration. Acceleration is a vector quantity, so acceleration may be non-uniform even if the body is changing direction. That is, if it is not moving along a linear path, then the motion will be non-uniformly accelerated motion. Let's now see and think about the objects and list examples of motions in which the acceleration is in the direction of motion, acceleration against the direction of motion, that is negative acceleration. The negative acceleration is also known as deceleration. uniform acceleration and examples of non-uniform acceleration. Now here are a few examples which will use the relation between acceleration, initial velocity and final velocity. You can see the example is starting from stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Here note, he is starting from stationary position, means initially the velocity is 0, the final velocity is 6 meter per second and the time taken is 30 seconds. Then he applies brakes such that velocity of the bicycle comes down to 4 meter per second in next 5 seconds. So there are two parts of motion. First part 30 seconds there is an increase in velocity, and next part of 5 seconds there is a decrease in velocity. Calculate the acceleration of bicycle in both the cases. Case 1, you have initial velocity u equal to 0, final velocity v is 6 meter per second, time is 30 seconds. So acceleration v minus u over t comes out to be 0.2 meter per second square. Positive acceleration means the acceleration is in the direction of motion of the body. Second case, the initial velocity is 6 meter per second, final velocity is 4 meter per second, time is 5 seconds. So acceleration is v minus u, v 4 and u is 6. So here the acceleration comes out to be minus 0.4 meter per second square. So negative sign implies that the acceleration is opposite to the direction of motion of the body. Such a motion is also called decelerated motion or motion with negative acceleration. Now here are some problems for practice. You may try them. They are based on what you have studied so far in this video, motion part 2. Now one more way of studying the motion is by means of graphs. Graphs, we know, are a very convenient method to present basic information about a variety of events in pictorial form. You must have seen in live telecasts of cricket matches, vertical bars represent the runs scored in a particular over. The graphs help us in solving linear equations having variables, two variables. This you have studied in mathematics, where you find the values of x and y by means of graph if two linear equations are given. The graphs which we use to describe motion of an object show dependence of one physical quantity, which may be distance or velocity, on another quantity such as time. Distance time graph, let's take up first. The change in position of an object with time can be represented by a distance time graph adopting a convenient scale of choice. Whenever time is one of the variables, it's invariably represented along x-axis. The other quantity here is distance, which we represent along y-axis on a suitable scale. We can draw the distance time graph of an object in motion under various conditions. Various conditions here means uniform speed, the object may be moving with non-uniform speed, or the object may be at rest. The shape of the graph depends on nature of motion, that is, it has different shape for objects at rest, for object in uniform motion, for object in non-uniform motion. An object moving with uniform speed travels equal distances in equal intervals of time. So the distance travelled by object is directly proportional to time for which it moves. We get a straight line graph in such cases. Remember, the distance time graph of an object moving with uniform speed is always a straight line. Here the part OB of the graph shows that distance increases at a constant rate. The term uniform velocity can replace uniform speed. That is, we can also call it displacement time graph. In such a graph, the magnitude of displacement replaces the distance along y-axis. The graph is as shown. The distance time graph can be used to determine the speed of an object. In order to find the speed, we can consider a part AB on the distance time graph as shown. We have to draw lines parallel to x-axis and y-axis from points A and B. These lines, they form a triangle ABC. AC here denotes the time interval T2 minus T1. AC, as you can see on the graph, gives us the time from T1 to T2. That is, the time taken here is T2 minus T1, and the distance is S2 minus S1. The ratio S2 minus S1, that is the distance covered, to the time taken T2 minus T1, gives us the speed of the particle. So speed is V equal to S2 minus S1 over T2 minus T1. The values of S2, S1, T2, T1 can be taken from the graph. We can also plot the distance time graph for accelerated motion. Remember, accelerated motion is a non-uniform motion. Here is an example. In this table, you have in the first column time in seconds. In the second column, we have time in meters, which represents the distance traveled by a car at regular intervals of time. As you can see, from 0 to 2 seconds, the car has traveled a distance of 1 meter. From 2 to 4, it has traveled 3 meter. That because it has moved from 1 meter position to 4 meter position. 4 to 6 meter, it has covered another 5 meters. That because it has gone from 4 meter distance to 9 meter distance, and so on. So since the distance covered in equal intervals of time is different, therefore the motion represented here in the tabular form is non-uniform. Non-uniform motion is clearly accelerated motion. Now, if we plot a graph here taking distance along y-axis and time along x-axis, the graph is a curve, non-linear graph. Non-linear graph represents non-uniform motion. The distance time graph for non-uniform motion is a curve. The shape of the graph is different from the distance time graph for uniform motion. You can recall distance time graph for uniform motion was a straight line, it was linear, whereas for the non-uniform motion, the distance time graph is a curve, which you can see on your screen. The variation of velocity with time for an object moving along a straight path can also be represented by velocity time graph. That is, we can also plot velocity time graph for accelerated motion. Again, here time is one of the variables which we will take along x-axis, and the velocity will be taken along y-axis. The graph will be called velocity time graph. For uniform velocity, the height of velocity time graph, that is CA or dB, will always remain unchanged because the velocity or speed is not changing with time. The graph here is a straight line parallel to time axis or x-axis. In this graph, we have represented the VT graph for a car moving at a uniform rate of 40 km per hour. We know that the velocity and time multiplied, that is the product of velocity and time, gives the displacement of an object moving with uniform velocity. This product is also the area under the velocity time graph. That is, if you find out the area under graph AB, part AB of the graph, the area is ABCD. This area gives the distance travelled by the car between time intervals t1 to t2. The velocity is represented by height AC or BD, and time is represented by the length AB or the length CD. The distance, as you can see, S is equal to AC multiplied by CD, 40 km per hour, into the time t2 minus t1 in hours. So the product here, or the area under the graph, will give us the distance covered. The uniformly accelerated motion can also be studied by plotting VT graph or the distance time graph. Let's consider a car being driven along a straight road for testing its engine. While testing, we want to find out in general the acceleration which the car engine can provide to the car. A person in the car records velocity of the car after every 5 seconds by noting the reading of the speedometer in the car. The velocity of the car in kilometer per hour as well as meter per second at different instants of time is given in the table. As you can see from the second column, the velocity is changing by equal amounts, that is 2.5 meter per second every 5 seconds. Such a motion will be a uniformly accelerated motion. The table is on your screen. See, from 0 to 5 seconds the velocity changes by 2.5 meter per second, 5 to 10 it again changes by 2.5 meter per second, and so on. The VT graph for such a motion, which is uniformly accelerated motion of the car, is as plotted. The graph VT graph is a straight line. The linear velocity time graph shows that the car is in uniformly accelerated motion. For non-uniformly accelerated motion, that is if the speed of a car or an object changes at variable rates, then the graph will be non-linear. It can have any shape. In the figure A, the graph A represents the case where velocity decreases with time. As you can see, it is steeping downward, so velocity is decreasing with time. Here the body has negative acceleration or the motion is decelerated. In the second graph B, sometimes in a part of the time the velocity is increasing, that is rate of change of velocity is positive, while in other parts it is negative, that is the motion is decelerated. So, this is a case of non-uniform acceleration. The velocity time graph for non-uniform acceleration can take any shape depending upon the variation in the velocity. So, you have to remember, you have to interpret the type of motion by studying the graphs. We can recall the distance time graph. If it is a straight line parallel to time axis, then the body is at rest. If distance time graph is a straight line non-parallel to the time axis, then the body is moving at a uniform rate, or it is in uniform motion. If the motion is non-uniform, then the distance time graph is a curve. Similarly, you can interpret the type of motion from velocity time graph of a body. You can take this example to further bring home the concept which you have learned. Here is an activity. You have time of arrival and departure of train between stations A, B and C, and the distance of stations B and C from A in the table. You can plot the distance time graph and interpret the type of motion, that is, you can find out whether the motion has been uniform or non-uniform. Here is another example. Firoz and his sister Sania go to school on their bicycles. Both start from home at the same time, but they follow same route and take different time to reach the school. The table shows the distance traveled by the brother and sister at different times. You may plot the graphs, see the shape of the graphs. It's advised that you choose the same scale for motion of both Sania and Firoz and try to interpret the graph. As you can see, Firoz reaches the school earlier and Sania takes 5 extra minutes to reach the school. So Firoz is driving faster, his speed is larger. The distance time graph for Firoz will be steeper. Remember, steeper the graph, faster is the motion, larger is the speed. Here are some problems for practice. Thanks for watching. Subscribe to physicsbackers.com for notification of further posts. You may provide your valuable feedback at the email ID given. Wish you all the best. Happy learning. Thank you.